Hi colleagues, welcome to the Digu Science channel that presents animation videos related to educational material. Previously, we could calculate the moment of inertia of the thin stick using the Riemann sum. This method seems to be the method that logic can understand best. There are other methods besides that. One of them is the integral method. What's that? Let's discuss. We want to calculate the moment of inertia of the thin stick, but this time the shaft is at a quarter of its length. Before we go any further, we need to place this thin stick in a three-dimensional Cartesian coordinate system. More precisely on the x-axis. And the axis of rotation passes through the coordinate center. If the length of this stick is L, then one of the endpoints will be at coordinates minus a quarter L, and the other end will be at coordinates 3/4L. In the integration process we must know the elements of integration. The smallest element that makes up that object. Suppose there is a very small element. Its length is dx, and its mass is dm. If this element is shifted from one endpoint towards the other endpoint, a stick is formed. From here, you already understand what is meant by the elements of integration. Elements that can form objects. Using the integration method, the moment of inertia of a rigid body about a certain axis can be calculated through the equation I, which is equal to the integral of r squared over the mass element dm. What is meant by r here is the distance from the mass element to the axis. Because it is on the x-axis, the distance is x. R is the same as x. Then what about the mass element dm? Let's just say this stick is a homogeneous stick. A stick that has uniform density at all points. Therefore, dm per dx equals big M over L. Or, dm equals big M over L, dx. We can substitute this dm value into the integration equation. The next issue is the limits of integration. To form a stick, the mass element moves from x equal to minus a quarter L to x equal to 3/4L. Thus the limit of integration is from minus a quarter L to 3/4L. The mass of the stick is fixed, and so is its length. The big M value per L can be excluded from integral notation. Now, the integration of x squared with respect to x is 1/3 of x cubed. Now, we can enter integration limits. The value in brackets is 7/48 cubic L. Thus, the value of the moment of inertia is 7/48 big M L squared. This is the moment of inertia of a thin stick rotating about an axis passing through 1/4 of its length. We have understood certain integral concepts in the integral course. This is not a complicated calculation. Hope it is useful. See you in the next video.